Friends, in WinGX, structure refinement is the process of improving an initial crystal structure model obtained from the structure solution stage. The goal is to adjust atomic position, bond lengths, angles, and thermal parameters to achieve the best possible fit between the model and the observed diffraction data. Models, whatever we have the calculated, and whatever the data is saying from the diffraction data. Here is a step-by-step breakdown of how structure refinement works in WinGX. Now, initial refinement stage. The initial structure model from the structure solution step is used as a starting point. Like refinement software, typically Shell Excel within WinGX, is configured with the appropriate parameters including atomic position, symmetric constraints, and symmetric constant is important. Constraints. And what is this meaning? I will discuss. And a space group information. The second, least square refinement. Least square refinement is the primary method used in WinGX to minimize the differences between the observed and calculated diffraction intensities. And this technique interactively adjusts atomic positions to reduce the R factor. R factor means R for residual factor. What is the residual factor? We will discuss more, which indicates the agreement between the observed and calculated data. Lower R factor means better agreements. Weighted least square refinement can also be used, applying weights to reflect the accuracy of specific measurements, further optimizing the model. Now, anisotropic and isotropic thermal parameter. You know, thermal parameters, also known as B factors or Debye-Waller factors. That is the one mathematical things. Describe the vibration of atoms in the crystals. Initially, atoms may be refined isotropically with a single parameters describing their motion in all direction. In later stage, anisotropic refinement is often applied to non-hydrogen atoms, allowing them to have different thermal parameters in different directions. And this adds initial to models, especially for heavier atoms. Now, refinement of hydrogen atom. Hydrogen atoms are often challenging to locate due to their low electron density. In the refinement stage, they may be placed in calculated positions based on the geometry of bonded atoms. Once positions, hydrogen atoms can be refined either as fixed entities or by allowing limited adjustment, typically isotropic refinement. Now, constraints and restraints. This two words is important. Constraints are applied to enforce non-structural symmetries or relations, such as setting bond angles or distances to specific values. For instance, in asymmetric molecules, certain atomic positions may be constrained to remain identical. Restraints are softer than constants. Restraints are softer than constants and are used when specific geometric values are expected but may have some flexibility. For example, restraining bond length within the certain ranges prevent unrealistic values without fixing them strictly. So these tools help maintain a chemically sensible structure throughout the refinement, especially in complex or distorted models. Residual density map analysis. You know, after each refinement cycle, uh, uh, Fourier difference map known as residual density map are generated. And these maps highlights area where electron density is not accounted for by the current models, indicating possible missing atoms or incorrect placement. Peaks in the residual density map can help locate unmodeled atoms or identify errors, allowing further refinement adjustment. Friends, validation and refinement diagnosis. The model is checked for errors and consistency using several indicators such as R factors, R1 and WR2, and goodness of fit, GOF, goodness. These values assess how well the refined model matches the observed data geometry parameters, bond lengths, bond angles, and thermal ellipsoid shapes are examined to ensure realistic value. Validation software, often integrated within WinGX or used alongside it, helps verify the refinement structure is chemically and crystallographically sensible. Friends, final refinements and report generation. Final refinement continue until no significant improvement are observed in the R factor and the model geometries and electron density fit. Once finalized, WinGX allows user to generate crystallographic information file CIF containing complete details of the refined structure. And this file can be submitted to database like the Cambridge Structural Database CSD or included in the publication. In summary, the structure refinement process in WinGX mainly performed with selection involve interactive adjustment to achieve an accurate and chemically sensible model by refining atomic position, thermal parameters, and using constants and restraints. Researchers ensure that the final structure closely represents the actual crystals, enabling reliable insight for further study and publications.